We have all used rendering engines to present our work, but the era is shifting, bringing new and better ways to present. For ages, it was perspective drawings, then handmade physical models, then static digital renders. Now, it's evolving into real-time digital twins. I realized today's software like Lumion and Twinmotion lacks a crucial feature: true free exploration. Think about open world games like Elden Ring or Skyrim. That freedom to explore is the selling point. Yet, there is no architectural software right now that presents your project with that exact kind of excitement. So, let's make one. Before we start building, we need a solid plan. To call this project 100% ready, we need 3 navigation modes, 5 unique tools, and a comprehensive settings panel. But even that's not enough. We aren't just building a standalone software, we are building a software template. Every unique user should be able to customize it to fit their brand while they're making it. That means the entire design must be customizable from a single central panel. And to future-proof it, most of the software needs to be based on UI elements, keeping the door open for touchscreen implementations down the line. A strong house needs a strong foundation. What does it take to create a brand? Colors and typography. We start by creating a data asset that holds 8 different colors, 3 main brand colors and 5 technical colors. For the font, we are using Inter from Google Fonts. It's clean, modern, and commercially free, so why not? To control everything from a single point, we set up a data table defining our text types. With that foundation, we build customizable text and image widgets to use across the entire project. We update them on the construct event, pulling our stored colors and font data. Then comes the crucial button widget. Inside, we pack an image, a spacer, and a text. We give this button 4 specific modes: a pre-enabled state that highlights before pressing, an activatable state that highlights on press, a fade-on idle state when not hovered, and a force activate state to cancel the activation on a second click. Now we have the pieces to build our main UI. We set up buttons for navigation modes, settings, and render. The compass goes on top, and tools sit on the right. The navigation mode button is activatable, revealing our modes when pressed. Tools remain permanently on screen to encourage use, while the compass is optional based on user preference. We live in an age of many things, so it's better to have fewer, highly functional features. Minimalism isn't just a style, it's a requirement. Like I mentioned, we need a bird's eye free roam, but we have to remember, we aren't making a game. The controls shouldn't feel like we are playing. They should feel native to BIM software. Personally, I love ArchiCAD's movement logic, but instead of the middle mouse button, we will map panning to the left mouse button. I honestly can't remember how many middle mouse buttons I have broken over the years trying to use that navigation. The scroll wheel handles zooming in and out. But this is a presentation space, not a design sandbox. We need boundaries. I enforce this by adding a distance-based clamper and binding a visual red sphere to define the borders. Unrestricted freedom is messy. Controlled freedom is professional. Have you ever experienced this? You are presenting a video, explaining a specific detail, and the camera just glides right past it to show something else. I absolutely hate that. It's time to fix it. With the second navigation mode, we force the camera to orbit around specific objects. A simple pawn won't cut it here. We need an actor blueprint. We drop these positions into the level, and they appear when we enter this mode. Click one, and the camera smoothly translates between the 2 points. After a user-defined delay, it begins a slow rotation around the object while you continue your speech. And of course, we have baked in a zoom feature. No more missed details, we control the focus. Our third navigation mode brings things back to human scale. You all must have used Google Street View. That node-based logic is actually perfect for multi-platform navigation. Let's adapt that and call it POV mode. We need 2 blueprints for this, one player pawn to handle the camera controls and a second blueprint for the physical points placed in the world. The pawn can look around freely, but it can only click to move between these points. The hardest part would be engineering the logic so these location points actually recognize each other and connect visually while we set up the level. It was a serious, complex challenge, but in the end, it works exactly as intended. Unreal Engine does a great job selling the emotional side of a project, but when you present technical work, you need hard data. We need the ability to take basic measurements in real time. I divide it into 3 modes. Measuring the distance from the camera to a click point, measuring between 2 click points, and measuring a radius. But building this is harder than it sounds. First off, these measurements have to appear as UI elements, not 3D objects in the world. 3D text puts unnecessary pressure on the hardware. Plus, if an object gets in the way, your measurement is blocked. And since you never know the scale of a project, a 3D measurement might be too tiny to read from a distance. So, we use UI elements driven by enumerations to switch behaviors based on the measurement mode. We also built in a history list so we can rewind our actions, and we made it save compatible for future presentations. Real-time accuracy whenever we need it. Next, we need a tool to display the project's metadata. Things like carbon emissions, walking distance to the nearest metro, or site photos. To keep it customizable, we create a metadata structure holding a text variable and an image variable to visually represent the data. Inside our actor blueprint, we create an array variable using that exact structure. This allows users to add as much information as they want. We also make sure to include a click to expand logic, keeping the screen clean until the data is actually needed. Context is everything. Okay, that's fine for the exterior, but what if you want to see inside? We need section cuts, and we need them in real time. This one is actually pretty easy. Instead of complex modeling, we use basic material parameters to mask the object. When you click an object, it activates a clipping plane. The material reads the plane's location and rotation data, and dynamically masks out the geometry based on that axis. It gives you instant, surgical precision to slice through a building on the fly. Let's say a client requests a revision right in the middle of a presentation. With the sticky note tool, we drop an actor into the world and attach the client's text directly to its stored widget. We don't need a scramble for a physical notebook. It's all recorded in the 3D digital environment. And because it's tied to the autosave system we will build next, it persists. Even after we make the revisions, those notes stay exactly where we left them unless we delete them, making it incredibly easy to address them in the follow-up meeting. We aren't just presenting, we are streamlining the workflow. And we come to our last and most visual tool, the path drawing tool. I used to try and explain circulation routes by waving a laser pointer at a screen or drawing over printed maps on a board. I found it totally ineffective, and I was never sure if the clients actually understood me. This tool fixes that entirely. It captures your click locations to create an array of vector 3 points. We take those vectors, generate a spline, and then use that spline to extrude a 3D line. To make sure every route doesn't look identical, we expose variables so you can give each line a unique name, change its color, and adjust its brightness. No more pointing and guessing. We are drawing the workflow right onto the architecture. Okay, all the features are built. Only one thing left. How do we customize and control all of this from a single place? They need to react to each other, save, load on startup, and communicate. We create Blueprint OmniViz for this exact purpose. It scans the world to see which pawns are used, toggles tools on and off, changes measurement units, controls the autosave intervals, updates branding colors, and sets project logos. As you can see, this blueprint is the brain of the operation. To handle the triggers between the widgets and the blueprints without bottlenecking the system, we strictly use event dispatchers and blueprint interfaces. Unreal Engine is visually stunning, but it takes most of the hardware's potential to deliver those graphics. If you want to show clients something that looks good, we need the underlying code to be lightweight. Sloppy logic kills frame rates. Optimization is the king. With that, our project is 100% complete. I have decided to package this up and put it on the Fab Marketplace. So if you want to try it out on your own projects, you can. What do you guys think of it? Let me know your thoughts in the comments. And tell me how we can improve it, because I am planning more updates in the coming months. If you want to learn the exact details of how to build these mechanics, hit like and subscribe so you don't miss the upcoming tutorial videos. I am looking forward for your feedbacks to creating those videos right now. See you in the next one.